Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in today's class, we would be focusing on some important concept of vectors. Vectors as part of paper 3, that is pure mathematics, paper 3, which is known as P3. Now, vectors is a very, very important topic. There are some things which we have already studied in our regular classes. That is about the basics of vectors, the addition, subtraction, the multiplication, the scalar multiple thing. 3D vectors, that is the x-axis, the y-axis, the z-axis, the magnitude of a vector, distance between 2 points. What are parallel vectors? They are scalar multiples of one another. The concept of unit vector is vector divided by its magnitude. Dot product A dot B. What is it used for? To find angle between two vectors, that is A modulus, B modulus, cosine of theta. Then we did some questions on 3D diagrams like this, in which I, J, K was given, and you just have to take a walk. So remember my words, take a walk around the edges and you are all set to go. And then the next level was a little bit advanced level. That is equation of a line in 3 dimensions, whether it's the vector form, whether it's the Cartesian form. How do we know if a point lies on a line? How can we find angle between two lines? That is angle between the direction vectors, the decision-making vector. And right now over here, these are the two topics, that two sub topics or concepts that we are focusing on, along with some past paper questions that we will get started with. So let's talk about parallel, intersecting, and skew lines. So first of all, let me focus on parallel. So line 1, let me write down few equations of line. Line 1, line 2, line 3, line 4, and maybe line 5. So therefore, R is equals to 1, 2, 3 plus lambda 2, 3, and negative 5. R is equals to 0, 1, 2. And let me write it a little bit bigger. It looks bad. That's 1, 1, 1. Let me change it. Doesn't make a difference. Plus mu times negative 2, negative 3, positive 5. R is equals to 2, 3, 7 plus nu times 4, 6, and negative 10. R is equals to 1, 2, 1 plus S times 2, 3, 5. R is equals to 1, 0, 1 plus T times minus 2, 3, minus 5. So there are 5 lines. And remember, when we talk about parallel, we are talking about the direction vectors. So let me aware you of the symbols that I use. I use PV for position vector, vector with respect to the origin. I use DV for direction vector, the decision making vector. So this is direction vector. We are aware of this thing. R is equals to A plus lambda B. R is a variable point. It could be any point on the line. A is like a fixed point on the line. B is direction vector. Lambda is a parameter. So some of the common symbols that we use, lambda, L-A-M-D-A, and then we have mu, and then we have nu, and later S and T, they are English alphabets. The other 3 were symbols. Now let's focus on this thing, that is 2, 3, negative 5. Let me focus on negative 2, negative 3, positive 5, 4, 6, negative 10. Then I have this one, the orange one, 2, 3, 5, and then the greenish one at the end. That's like this. So instead of greenish one, let me use another one. I think red is good. Now let's focus on the direction vectors. So now this is direction vector 1. Let's keep this as the standard. Direction vector 1 is 2, 3, and negative 5. Is direction vector 2 a scalar multiple? The answer is yes. Because if I focus on this 2 negatives and 1 positive, as opposed to 2 positive and 1 negative, it's uniformly changed. So direction vector 2 is parallel to direction vector 1. Therefore, line 1 and line 2 are parallel. What about line 3? We are talking about direction vector 3. This is positive, this is positive, this is negative, this is double of that. So direction vector 3 is 2 times direction vector 1. So of course, these two are also parallel. All good, all clear? Now, what about this one? All these three are positive. So just discard it right away because these two were positive. This is negative. So this is not parallel. And similarly, negative, positive, negative, this is also not parallel. So therefore, bottom line of the story is, in order for a vector to be parallel, so let me write over here, in order for a vector to be parallel, so parallel vectors are scalar multiples of one another. That is one thing. And that goes for the direction vectors. If the direction vectors are scalar multiples, then it means the lines are parallel. And we know that parallel lines never meet each other. Or some say they meet at infinity, but who has seen infinity? Okay, so that is the concept of parallel. Now, let me add a line and let me focus on intersecting. So when we talk about intersecting, and let me compare it with skew lines. So what is the difference between the two? Theoretically, if I have this piece of paper, let's say it's a square piece of paper. And in the square piece of paper, if I draw two lines, let's say I have drawn one line like this, and I have drawn another line like this. So this is line 1, this is line 2, and two non-parallel coplanar lines will intersect. Non-parallel, that is obvious. What is the meaning of the word coplanar? It means on the same plane. On the same plane, on the same surface. That surface could be the tablet, the iPad that I'm using. That surface could be the whiteboard that I use in class. That surface could be your notebook page that you use. So all these things are the surface. If two lines are not parallel on the same surface, they will intersect. And there is a process of showing it. So you have to show some calculation, which is coming up on the next page. So calculation based, it's not some diagrammatically based, it's all calculation based coming on the next page. And what is skew? Skew is like, let me give you the idea. Let me draw a square like this. And let me draw, no, I don't need this, my bad. So like this, and let me just erase this thing. And let me draw another square. And let me also erase this thing. And let me just join it using some lines. Now let's say this is a room and there is a line on the top. So there is a line at the ceiling. So this line is line 1. Line L1 is at the ceiling. And let me draw another line at the bottom. That is line 2 that goes over here. So let me choose green, blue, red, purple, I think pink. So let me draw another line over here. That is line 2. So L2 is on the floor. Two different surfaces, two different planes. Doesn't make a difference. It could be parallel. It could be not parallel. Such lines are called skew lines. So non-parallel, non-intersecting lines they are called skew lines, and it's the same calculation that is for intersect. Now, let me show it with the calculation, and then you will acknowledge me on the WhatsApp whether you have understood it thoroughly or not. So now the calculation is the same for intersecting versus skew. So it says show that the lines with vector equations intersect and find the position vector of the point of intersection. So line 1, r is equals to 3, 8, negative 2. And this is t multiplying with 2, minus 1, and 3. And line 2, r is equals to 7, 4, 3 plus t multiplying with 2, 1, 4. 2, 1, 4. That is the thing. These are the two lines. The first thing is expand it out. 3 plus 2t, 8 minus t, minus 2 plus 3t. That is line 1. Line 2, that is 7 plus 2t, 4 plus t, and 3 plus 4t. Now, the thing is, if two lines intersect, they will have a common point. So intersecting lines have a common point. And if they have a common point, the x coordinate, the y coordinate, the z coordinate, that should be the same from both the lines. So if I just do a little bit of highlighting, so the x coordinate should be the same, the y coordinate should be the same, the z coordinate should be the same. So there are three equations that can be formed. So the first equation in red color, that is this one. And the second equation in blue color. So let me just write two of them for right now. So the first one is 3 plus 2t equals to 7 plus 2t. And let me just double check. I think that is a minus 3, 8 minus 2, and 2 minus 1, 3. 2 minus 1, 3, all good. And 7, 4, 3, 7, 4, 3 is good. And 2, 1, 4, that is also good. So 3 plus 2t is equals to 7 plus, it's not t, it's s, my bad. The first one is t, the second one is s. So that is the mistake that I've made. So let me just correct myself. Otherwise, I was just wondering how is it canceling out. So this is s, so 7 plus 2s, 4 plus s, and 3 plus 4s. Let me use the same colors over here, the red, the blue, and the green. And over here, let me just erase this whole thing. So now the first thing is the red one. That is 7 plus 3 plus 2t is equals to 7 plus 2s. That is equation 1. 8 minus t is equals to 4 plus s. That is equation 2. Let's solve these two simultaneously. Let me use equation 2. And 8 minus 4 is 4 minus t equals to s. That is what you find. And substitute it over here. 3 plus 2t is equals to 7 plus 2 times s. That is 4 minus t. That is 7 plus 8 minus 2t. That is 3 plus 2t. And 7 plus 8 is 15. 15 minus 3, that is 12, and this is 40. Therefore, t comes out to be 3. Once you get t is equals to 3, therefore 4 minus 3 equals to s. Therefore, s comes out to be 1. Got it? All good? All clear? Now, what is the third equation for? The third equation is for checking. So now the third equation is minus 2 plus 3t minus 2 plus 3t is it equal to 3 plus 4s. 3 plus 4s. Plug in, and check whether it's valid for all three equations. So minus 2 plus 3 times 3 is it equal to 3 plus 4 times 1. This is 7. 9 minus 2 is 7. Yes, it's equal. Therefore, s and t, the parameter, satisfies all three equations. Therefore, the conclusion is lines intersect. Let me add a page. If not, we will say the lines are skew. That is the working that we do. So now we have proven that the lines intersect, all good. Now let me write the equations one again for R. 3 plus 2t, 8 minus t, 3 plus 2t, 8 minus t, and the third one is minus 2 plus 3t, minus 2 plus 3t. Let me write the other one in terms of S, 7 plus 2s, 4 plus s, 7 plus 2s, 4 plus s, and the last one is 3 plus 4s. So either you place t where it belongs. So either you place t where it belongs or you place s where it belongs. So t and then s. So t is 3, s is 1, plug in to find point of intersection. So therefore, R is equals to 3 plus 2 times 3, 8 minus 3, minus 2 plus 3 times 3. 6 plus 3 is 9, 8 minus 3 is 5, this is 7, 9, 5, 7. So the position vector of point of intersection is 9, 5, 7. If they would have asked for coordinates of point of intersection, just write it horizontally, which is 9, 5, 7. Double check with S is equals to 1. R is equals to 7 plus 2 times 1, 4 plus 1, 3 plus 4 times 1. So 7 plus 2 is 9, 4 plus 1 is 5, 3 plus 4 is 7. Of course, it will give the same answer. So your choice whether to plug t is equals to 3 in its relevant equation or s is equals to 1 in its relevant equation, just do one of them. Just plug it in one of the two equations to find point of intersection. Point of intersection. Now, is it all good, all clear? So let me first send you this thing so you can copy this down and make sure that you have understood it, because that is what the next question will be all about. Okay, so I'll just share this thing with you and then you can copy it down. So no, I'm just, hold for a second, just close this. And I think this is about this thing, and this is the revision thing that we have done so far. So let me stop over here. And then I'll give you a question also. Let me just paste the question and then I'll stop the recording. Lines askew. I'm looking for intersection, perpendicular distance, do not intersect, LMM intersect, and then the angle thing. So question number 15 from the exercise that you have, that's for 7 marks. Angle is between the direction vector, the dot product. So this question is pasted over here. Now I'll share all these images for you to copy and then try it out. So let me pause the recording. So now let's get started with this question. It says, it's a past paper question. The lines L and M, highlight कर लेते हैं, ये एक line है, this is L, और ये दूसरी line है M. These two lines are there. Show that the lines intersect. They are not asking us for the point of intersection. They are simply asking us the intersection and calculate the acute angle between the lines. First of all, write it down. Line L, expand. So this is 1, R is equals to 111 plus S times 1 minus 1 in 2. Line M, R is equals to 461 plus T times 221. It's always a good idea to double check. 1, 1, 1, 1, 1, 1, 1, negative 1, 2, 1, negative 1, 2, 461, 461. 2, 2, 1, 2, 2, 1. There is a T over here. There is an S over here. All good, all clear. Expand it. 1 plus S, 1 minus S, 1 plus 2S. Expand it. 4 plus 2T, 6 plus 2T, 1 plus T. And let me write this for a little bit properly. Now the markers, the red marker, no, not this one. Hold for a second. Over here, the red one, this equals to this. You can solve any two equations and check in the third one, this and this. So now if I solve 1 plus S is equals to 4 plus 2T, therefore S is 4 minus 1 is 3, 3 plus 2T. That is this thing, the red one, that is over here. And then let me talk about the blue one. That is 1 minus S, that is equals to 6 plus 2T. And if I make S the subject, so therefore I'll just plug it in. So 1 minus 3 plus 2T is equals to 6 plus 2T. 1 minus 3 minus 2T is 6 plus 2T. So therefore 1 minus 6 minus 1 minus 3 minus 6. 1 minus 3 minus 6 is equals to 2T plus 2T, which is 4T. So negative 9 plus 1 is negative 8 is 4T. Therefore T comes out to be negative 2. Therefore S comes out to be 3 plus 2 times negative 2. That is 3 minus 3 plus negative 4. That comes out to be negative 1. So therefore T is negative 2, S is negative 1. Check in equation 3. The third remaining equation, that is the green one. So the green is 1 plus 2S, 1 plus T. 1 plus 2S, 1 plus T. T is negative 2. So this is 1 plus negative 2, which comes out to be negative 1. And S is negative 1. 1 plus 2 times negative 1, which is 1 minus 2. And that is also negative 1. So negative 1 is negative 1. Yes, S and T, the parameters satisfies all three equations. Therefore, the conclusion is lines intersect. That's all about it. We are not interested in finding the point of intersection. Let me add a page over here. Let me copy this image and let me paste it over here. And I'll also show you the mark scheme in a short while. Calculate the acute angle between the lines. So direction vector of line L, that is 1, 1, negative 2. Direction vector of line 2 is 2, 2, and 1. Let me highlight it for you. So let me highlight this. That is 1, minus 1, and 2. And the other one, the orange one, that is 2, 2, 1. This is 2, 2, 1. That's good. And 1, minus 1, and 2. Okay, I just made a mistake over here. So let me correct my mistake. Okay, that is why rechecking is very important. 1, minus 1, and 2. So the purple thing, that's right over here. So magnitude of direction vector of line L, that is 1 square, 1 square, 2 square. I have deliberately ignored this negative sign because after squaring, it will become positive. 4 plus 2, that is 6. Direction vector 2, I just need to take the magnitude. That is 2 square, 2 square, 1 square, under root, 4 plus 4, 8, 8 plus 1 is 9, square root of 9 or 3. Direction vector of line L dot product with direction vector of line M. Instead of 2, let me write M. So this is M over here, this is M over here, this is M, this is M. That is equals to direction vector L magnitude, direction vector M magnitude, cosine of theta. So 1, minus 1, and 2, 1, negative 1, and 2, dot product with 2, 2, 1. 2, 2, 1, no harm in double checking. That is root 6. And this is root 9 cosine theta. I can use root 9, I can use 3. 1 minus 1, 2, 2, 2, 1, all good. So now multiply out this way, the red with the red, the blue with the blue, and the green with the green. So let me write over here the red thing, that comes at the end, the green thing, the blue thing, the red thing, and then we will divide by these two magnitudes. That is this one, the purple one, that goes over here, and this orangish one that goes over here. All good, all clear? So now this is 1 into 2 is 2, plus minus 1 into 2 is negative 2, plus 2 into 1 is 2, divided by root 6, root 9 is equals to cosine of theta. So 2 cancels out. And this is 2 over root 6 root 9 is cosine theta. Therefore, theta is cosine inverse of 2 over root 6 root 9. And you will find the value of theta. So this is question number 15. Let me go to the mark scheme. Question number 15, 11, 15. That's right over here. And let me just paste this thing. Okay, let me copy this thing. Okay. So now the first part was all done. That is this thing. That is, hold for a second. That is S is -1 or T is -2. That thing was done. Verify that all three component equations are satisfied. That thing is done. And then we have this thing, which is carry out the process for evaluating the scalar product of the direction vectors of L and M. Use the correct process for the moduli. Divide the scalar product by the product of the moduli. Evaluate the inverse cosine. Obtain answer 74.3, 1.30 degrees, 1.30 radians. Both are acceptable. So I'm working in degrees. That is 74.2 degrees, correct to 1 decimal place. Or if you write in radians, theta is 1.30 radians, correct to 3 significant figures. That's your choice. Whether you do it this way or whether you do it this particular way, both are acceptable. All good, all clear? So just acknowledge it on the WhatsApp. Let me first write it down. That is the intersection concept. Intersection, question 15. All good, all clear? And I'll just pause for Azan. So now let's continue with the last concept. And that is about perpendicular distance from point to a line. Now let's say there is a line like this. A line has this equation, R is equals to A plus lambda B. And there is a point over here. Let me mark a point. And from this point, I'm interested in finding the perpendicular distance all the way up till here. Let me mark this point as R. R can be written over here in terms of lambda. So OR will be written in terms of lambda. Then we can find QR, which I'll show you in a short while. And then since this is perpendicular, therefore, QR is perpendicular to the line. QR is perpendicular to direction vector of the line. Therefore, QR dot product with direction vector of the line should equal to 0. So I'll obtain a value of lambda. Once I obtain a value of lambda, plug in either OR to find coordinates of R, or plug in QR and then find the magnitude of QR to find the distance. First, go through the things that I've explained. I want you to focus on it, and then I'll go over it once more. First, go through it. Now, let me explain. What we will do is this. It's a 5-step process, 5 basic simple steps. The equation of a line is here. There is a point. I drop a perpendicular. The point where I get the perpendicular, which is known as foot of perpendicular, I write OR, the position vector of that point in terms of lambda by expanding this equation. Then I'll find QR, which is OR minus OQ. Now this vector is perpendicular to this. I'll do dot product. For perpendicular vectors, the dot product is 0. I'll find a value of lambda. If I plug in the value of lambda in OR, I'll get the coordinates or position vector of R. If I plug in QR, I'll get this vector QR, and I'll find the magnitude of this. I'll get the distance. As simple as this. Now, let's look at this question. It says the point P has position vector such and such. So first of all, let me write it down. OP, that is 3, -2, and 1. And the equation of this line L is R is equals to 4 plus mu, 2 plus 2 mu. I'm expanding it directly, and 5 plus 3 mu. That is the equation of this. Let this point, let me call it OR. So that is 4 plus mu, 2 plus 2 mu, and 5 plus 3 mu. Now let me draw a diagram. First of all, let me use the same color, that is red. So I'm using the same color over here. And let me use purple over here like this. So instead of Q, there is a P over here, that is 3, -2, and 1. This point over here is R. This is 90 degrees. So step 1 is writing OR. Step 2 is finding PR. That is OR minus OP. That is 4 plus mu, 2 plus 2 mu, 5 plus 3 mu, minus OP, which is 3 minus 2 and 1. That's 3, -2, and 1. 4 minus 3 is 1. So that is U plus 1. 2 minus minus 2 is 4. That is 2 mu plus 4. I'm just changing the order. Doesn't make a difference. 5 minus 1 is 4. That is 3U plus 4. That is PR. Are these two steps clear? Just have a look and acknowledge it on the WhatsApp. So let me write it. That is perpendicular distance from point to a line. And the first two steps. So are these two steps all good, all clear? Okay, I'll wait for your response. A2 Math 1, A2 Math 2. Okay. Okay, to Math 1. Okay. So now this is all good, all clear. Now, what is the third step? The third step is perpendicularity. So let me write over here. Step number 3. Step number 3. That is PR is perpendicular to line. PR is perpendicular to line L. PR is perpendicular to direction vector of line L. PR dot product with direction vector of line L should equal to 0. That is a property of perpendicular vectors. Direction vector of line L is 1, 2, 3. So this is 1, 2, and 3. And this equals to 0. There is a dot product and PR is right over here. That is PR. Mu plus 1, 2 mu plus 4, and 3 mu plus 4. So now let me do the dot product. So again, some coloring. This multiplies with this multiplies with this, and this green multiplies with this. So therefore, just extend it. So mu plus 1 into 1 plus 2 mu plus 4 into 2, and this is 3 mu plus 4 into 3 equals to 0. Let me double check my working. before I make a mistake somewhere else. This is 3, negative 2, 1. 3, negative 2, 1. Good. This is 4. This is mu. 4 plus mu. This is 2. This is 2 mu. This is 5. This is 3 mu. Then what I did is that 4 plus mu minus 3, that is 1 plus mu or mu plus 1. 2 plus 2 mu minus minus 2. This is minus 2. Yes, it's minus 2. That is 2u plus 4. 5 plus 3 mu minus 1. 5 minus 1 is 4. 3 mu plus 4. Mu plus 1, 2 mu plus 4, 3 mu plus 4. That's good. 1, 2, 3. 1, 2, 3 is over here. All good. Equal to 0. So now multiply it out. That is mu plus 1 plus 4 mu plus 8. That is 9 mu plus 12 equals to 0. So we have mu, we have 4 mu, we have 9 mu, 10, 14 mu. We have 1, we have 8, we have 12. So 12 plus 8 is 20 plus 1, 21 is equals to negative 21. Therefore, mu comes out to be negative 21 over 14. 7 3s are, 7 2s are. Negative 3 over 2, that's the value of mu. Now, let me pause over here. Let me go to the mark scheme and let me get this thing right over here. I think that's question number 1. So question number 1 is this one. I think, yes. Okay. So now there are different ways that they have done. Let me just capture, hold for a second. I cannot minimize it. That would be a problem. Let me just copy whatever I can see up till here. Okay. So let me add a page and let me go through it. It says find PQ or QP. So Q, they have used the word, the letter Q instead of R. 1 plus mu I, 4 plus 2 mu j, 4 plus 3 mu k, scalar product of PQ, direction vector equate to 0. We get mu s minus 3 over 2. We get mu s minus 3 over 2. I was just wondering about that. So yes, you do get this answer. So 3 steps are done. So let me recap. The first step, that is simply writing it down. OR, just expand the equation. The second step, subtraction. The third step, that is the perpendicularity. Now comes the fourth step. That is step number 4. We have mu equals to negative 3 over 2. Plug in QR. So PR. So this is what we are using, PR. So what is PR? Mu plus 1, 2 mu plus 4. PR is mu plus 1, 2 mu plus 4, and 3 mu plus 4. Mu is negative 3 over 2. So negative 3 over 2 plus 1. 2 into negative 3 over 2 plus 4. 3 into negative 3 over 2 plus 4. And yes, you do get these weird numbers. Negative 3 over 2 plus 1 is negative half. This is negative 3 plus 4 is 1. This is negative 9 over 2 plus 4, which is negative half. This is your PR. So step 4 is done. And step 5 is magnitude of PR, because you're looking for the distance. That is half square. That is 1 square. That is half square under root. So this is 1/4. This is 1. This is 1/4 under root. That is square root of 1.5. Square root of 1.5. And let me grab my calculator. So square root of 1.5. So scientific calculator is there. 1.5 is there. Square root is there. This comes out to be 1.2247. So this is 1.2247. And what is the level of accuracy that they're asking? 3 SF. So that is 3 SF. Therefore, this is 1.22 units. That is the answer for the magnitude of PR, which is the perpendicular distance from point to a line. So that's step number 4. This is step number 5. And that is how it's done. And let me check the working. Where is it? There it is. Obtain answer 1.22. So it's all done and dusted. All good, all clear. So let me just share this image with you so that not only can you copy this, you should be able to try out one other question of the same type. So let me just share the working with you. Okay. And let me pause the recording. Let me first add a question. So I need one other question, perpendicular distance. Prove that the lines intersect. I'm just looking for this thing, acute angle, position vector, acute angle, perpendicular distance. I think this is the one, question 11. And let me paste it first. So now this is question 11 over here. And let me also paste the solution for this, not the solution, the mark scheme. Question 9, 10, 11. Okay. So I think the first two method would suffice. This is part 1. The answer is root 104. That is what you should be interested in. Okay. So now I'm pausing the recording. And let's continue with this. So there is the Zoom and the recording is paused. Resume recording. Achaji, now let's look at this question, the last question for today. That is the point P has coordinates such and such. So OP is -1, 4, and 11. And the line L has this equation R. So let me expand R. R is equals to 1 plus 2 lambda, 3 plus lambda, minus 4 plus 3 lambda. Let's double check. -1, 4, 11, -1, 4, 11, good. 1 plus 2 lambda, 1 plus 2 lambda, 3 plus 1 lambda, 3 plus 1 lambda, -4 plus 3 lambda, -4 plus 3 lambda. And let me write this point as OQ. This is a point on the line where the perpendicular is formed. This is foot of perpendicular. So let me draw a diagram. So therefore, that is the line that's going like this. And it's going like this. And let's say this is the point P. This is the point Q. And that is step number 1. That is OQ. Step number 2. That is PQ. You can find PQ. You can find QP. Doesn't make a difference. So PQ, that is OQ minus OP. OQ minus OP. So this is 1 plus 2 lambda. This is 3 plus lambda. And this is -4 plus 3 lambda minus OP, which is -1, 4, and 11. So 1 minus -1 is 2. This is 2 plus 2 lambda. 3 minus 4 is -1 plus lambda. -4 minus 11 is -15 plus 3 lambda. This is PQ. Step 3. PQ is perpendicular to direction vector of line. So therefore, PQ dot product with direction vector of line L should equal to 0. 2 plus 2 lambda minus 1 plus lambda. And this is -15 plus 3 lambda. Dot product with direction vector of line equals to 0. What is the direction vector of the line? That is 2, 1, and 3. That is 2, 1, and 3. So let's multiply. This goes with this. This goes with this. This goes with this. So let's multiply it out. That is 4 plus 4 lambda. This is -1 plus lambda. This is after multiplication. This is -45 plus 9 lambda equals to 0. So we have 4 lambda, we have 9 lambda. 9 plus 1 is 10, 10 plus 4 is 14. Just a beautiful coincidence, just like last time. And then we have positive 4, we have negative 1, we have negative 45. So negative 46 plus 4 is negative 42. So take to the other side, that is positive 42. Therefore, the value of lambda is 42 over 14, which is 3. So now let's complete the question. The first 3 steps are done. Let's go through them once again. The first thing is that you draw a diagram and you write down the coordinates of the foot of perpendicular, which I have labeled as OQ by expanding the equation. The second step is find PQ. That is OQ minus OP, and this is what we get. Third step, PQ is perpendicular to the line. The dot product of PQ and the direction vector is 0. That gives us lambda is equals to 3. Let's double check. So over here, they have used the symbol n, and the value of n is coming out to be 3. So now let's do the next 2 steps. So now step number 4. That is, you have obtained the value of lambda, and we are interested in the perpendicular distance. That is the magnitude of PQ. So therefore, let me write PQ once again. That is in terms of lambda, 2 plus 2 lambda, 2 plus 2 lambda, minus 1 plus lambda, and the other one is minus 15 plus 3 lambda. And let me shift this up a little bit. So now let me put it over here. And now let me plug in the value of lambda, which is 3. So therefore, 2 plus 2 times something, minus 1 plus something, minus 15 plus 3 times something. And that something is the value of lambda. So therefore, let me write 3 over here, 3 over here, and 3 over here. And let me expand. 2 into 3 is 6, 6 plus 2 is 8, 3 minus 1, that's 2, 3 into 3 is 9, the difference between 15 and 9 is 6 with a negative sign. So therefore, this is what PQ is. And step number 5, that is the perpendicular distance, that is magnitude of PQ, which is 8 square, negative 2, actually positive 2 square, negative 6 square under root. This is 64, this is 4, and this is 36. 64 and 36 adds up to 100. So therefore, this is square root of 104 units. And let's double check the answer. So that is square root of 104 units, and that is the answer. So now in this particular video, we understood 2 concepts. That is, the first one is about parallel and intersecting and skew lines, and the next one was about perpendicular distance from point to a line. And that finishes this particular video. Stay tuned for more content on Mathematics with Shahab Yaqub.